What if robots could plan their next move the way an artist reveals a painting by refining noise into clarity step by step? I'm Dr. Kamarul Islam. A new wave in robotics is diffusion policies, generative models that don't just classify the world, they synthesize actions instead of predicting one command at a time. The robot samples a whole sequence of motions from noise and iteratively denoises it into a safe, efficient plan. In benchmarks across many manipulation tasks, this approach has shown a strong, often state-of-the-art performance because it handles multi-modal decisions and high-dimensional actions gracefully. You are already seeing this idea scale. Octo is an open transformer-based diffusion policy pre-trained on 800K robot episodes from the Open X-Embodiment corpus, then quickly fine-tuned to new robots, sensors and action spaces. Think general skills first, specialize later. On the industry side, PyO binds a vision language backbone with flow matching, a diffusion family technique to generate high-frequency dexterous actions from language prompts pointing to homes, clinics and service settings where robots adapt on the fly. Diffusion isn't just for hands, it's for paths. In motion planning, diffusion models learn distribution over feasible trajectories, letting robots navigate clutter or unseen obstacles by sampling and denoising candidate paths and even coordinating multi-robot motion under uncertainty. Why this matter for us? These models are age-friendly and data efficient once pre-trained. Pair them with our sensor stacks, vision, touch and gas or acoustic cues, and you get robots that propose a multiple safe solutions in milliseconds. Then commit to the best one with onboard compute. That's the leap